Hi, I'm Who Are We, and today we're diving into object-based attention in real-world scenes. An introduction to visual attention. Our visual world is filled with far more information than we can process at any given moment. To interact effectively with this information, our brain uses attentional mechanisms to selectively focus on certain regions or features of a scene. Attention can be directed based on low-level features such as contrast and brightness, or high-level factors such as semantic meaning. For example, recognizing a kitchen or park. However, there is a mid-level factor, object-based attention, that plays a significant role in how we navigate and process visual scenes. This lecture will explore how attention is guided by object-based representations in real-world scenes. What is object-based attention? Object-based attention refers to the idea that when we focus on specific locations within an object, our attention extends to the entire object, not just specific locations we are fixating on. Research shows that attention is more effectively allocated to objects rather than to the background of a scene. This object advantage plays a crucial role in how we process complex environments. The research question. The study we are discussing aimed to investigate whether object-based attention influences the way we process complex real-world scenes. Specifically, do object representations guide attentional selection in a way that enhances our interaction with real-world environments? Experimental design. Participants. 18 participants with normal or corrected to normal vision. Methodology. Participants viewed images of real-world scenes such as kitchens or outdoor environments, while their eye movements were recorded. Each image contained multiple objects, and participants were instructed to fixate on a cue, an apple, that appeared on one object. After fixating on the cue, a target object, a light bulb, appeared either on the same object as the cue, on a different object, or floating in space, used as a baseline condition. The key task for the participant was to shift their gaze to the light bulb to perform a simple discrimination task, identifying whether the light bulb contained T or L. Measurements. Response time, RTs, how quickly participants responded to the target, and initial saccade latency, ISL, how quickly participants initiated their eye movements toward the target after its appearance. Key finding. 1. Object-based advantage. Participants were significantly faster in both response times and initial saccade latencies when the target appeared on the same object as the cue. This suggests that when attention is focused on an object, the entire object benefits from enhanced attentional processing. 2. Object versus space. When a target appeared on a different object or floating in space, participants' response times were slower. However, there was no significant difference between targets that appeared on a different object and those floating in space. This indicates that the attentional benefit comes from focusing on the same object, not just from attending to a specific location in space. 3. Temporal and spatial facilitation. Faster initial saccades to the same object suggests that attention is distributed across the entire object, facilitating quicker eye movements to regions within that object. This effect is not simply about spatial proximity, but about the object itself guiding attention. Control experiments. The research conducted control experiments to rule out alternative explanations. One hypothesis was that visual clutter or perceived distance between objects could influence the results. However, these factors were ruled out, confirming that the faster responses in the same object condition were indeed due to object-based attention and not low-level visual noise or perceived distance. General discussion and implications. The study demonstrates that object-based attention is a powerful mid-level factor that operates continuously in real-world scenes. Even in the presence of other low-level, e.g. contrast, and high-level, e.g. semantic meaning factors, object representations still guide attention. This finding is crucial for understanding how we interact with complex visual environments efficiently. Object-based attention ensures that when we focus on specific objects in a scene, we can process other parts of the object more quickly and efficiently. This mechanism allows us to interact with our environment in a way that prioritizes either entire objects rather than arbitrary spatial regions. Key takeaways. Number 1. Object-based attention. Our attention extends beyond the point of fixation to the entire object, facilitating faster and more efficient processing. Real-world relevance. This mechanism is not limited to simple geometric shapes, but applies to complex real-world scenes. Efficiency in visual search. Object-based attention allows us to navigate scenes by prioritizing objects, which is crucial for tasks like searching for items in cluttered environments. This concludes our lecture on how object-based attention operates in real-world scenes and enhances visual processing.